go away.
Hi. Yeah, just tell things to go away. It's going to beep at me a lot because I'm presenting on the other screen. So,
Just
so welcome. So, seating in here. It's probably your seat's gonna change probably every day, but that's all right because we'll just spend the first couple minutes. You know, when you come in, just don't sit down unless you remember where you sit. But I've got to know where you sit because of the whole 6-foot rule and that stuff. So it didn't work to go 3-2-3. I kind of like to do you know 3 in the front and then 2 in the next row, and so it gives you more space because diagonal is more space than horizontal or vertical. So, but it didn't work out. There's 9 of you, so whatever. But you got to kind of sit here because of contact tracing and all that fun stuff. So yeah, remember where you sit. I literally went alphabetical. I started there and I went here and then I went there. And actually, no, I lied. I went this way and I zigzagged it this way. So okay. The only other thing that I have to talk about is when you are, well, first off, you should check It's Learning every day, still, whether you're here or whether you're not here, okay? So, because there was supposed to be a video yesterday, a quick video yesterday, but I forgot to post it, so that was my fault. Because when I was checking, I'm like, oh, I totally forgot. But anyway, so check It's Learning every single day. Homeworks are still going to be turned in online. Okay? So, and I didn't get you a hard copy of it yet because I didn't have time yet today to make it. But I will give you tomorrow. I'll give you a hard copy of the homework if you want. Okay? If you want to just print it out, that's fine. It's online and everything's ready to go. Those will still be due on Sunday nights at 11:59 p.m. Just like normal. Okay? Just like we have been doing throughout the year. Trying to keep as much stuff as we've done, as we've already started. Keep that consistency the same. Okay? When you are, so next week you guys go virtual. Okay? When you're virtual, if you want to attend class, that's fine. Okay? I will have, just like we have here, I'll have the presentation up on the big board, and I have the Google Meet open on the small screen. Okay? So if you want to attend class instead of watching the video for that particular day, by all means. Okay? I teach Algebra 3 from 10 to 11 and from 1 to 2 every day, except Tuesdays. Okay? So if you want to come in, it's the same Google Meet code as before, West Algebra 3. You can come in, and then that you can get. Then that way, if you have a question or something during class, I can answer it, or if you need some clarifications or something like that. Okay. Otherwise, you got to watch the video, which is going to just be like you guys right now are the video for today because I couldn't figure it out this morning because it was my first time logging in and everything was going on. Okay. So you got those options. Next week, when you guys are virtual, your 2 live days are still Monday and Thursday. So those days you have to log in still. But again, if it works out better for you to go to the other one on those days, I'm totally fine. Because you guys will be virtual and you won't be in them. So that's totally fine. Okay? Any questions for me? All right, let's get after it, man. Okay? So, first off, there's our function. F of x equals x cubed minus 5x squared plus 3x minus 10. Please find me what f of -2 and f of +3 are. So f of -2 and f of +3. So negative 2 cubed is negative 8. Negative 2 squared is positive 4. Positive 4 times negative 5 is negative 20. 3 times negative 2 is negative 6. Negative 8 minus 20 is negative 28. Minus 6 is negative 34. Minus 10 is negative 44. What I get. Yes? No? Maybe? Yeah? Okay. F of 3, then, is 3 cubed. 3 squared. 3 times 3. That will be 27 minus 45. 10, I'm thinking that is negative 19. 27 minus 45 is negative 18, plus 9 is negative 9, minus 10 is negative 18. Agree? Now, that works. You can always plug something in like that, okay? But there's a faster way, okay? And there's an easier way, okay? So let's investigate that. Okay? And that's called synthetic substitution, okay? Synthetic substitution has two parts to it. So first off, you have all of these coefficients of your terms, and you write those in order, in standard form order. So if we had a missing term, like if this function didn't have an x squared term in it, we'd have to have a placeholder there of 0. Okay, so we'd still have 0 placeholders like we had before. Okay? Then this number out here is what you're finding f of. So in this case, we wanted to find f of negative 2. Okay? Which is the same function that we just found, so we should get negative 44 here at the end. Okay? So what we do then is we take this first number and we drop it down. Okay? So we get 1. Then we multiply those two together, and that gives us negative 2. And then we add those two numbers together. Then we take this number, we multiply it again. So that's going to be 14. We add those two numbers together. Then we take this number, multiply it here one last time. It's negative 34. Add those two numbers together, and we get negative 44 as our answer. So f of negative 2 is negative 44, just like we had on the last slide. Yes, ma'am? No, because it's way down at the other end of the school. Yeah, sorry. If you want to waste 10 minutes, go ahead. But we're going to have a lot of good information here in the next 10 minutes. That's kind of important. Yeah. So this one we should get down here at the end. What do we say? Negative 19? Okay? So 1 is 1, times 3 is 3, negative 5 plus 3 is negative 2, negative 2 times 3 is negative 6, negative 3, negative 3 times 3 is negative 9, added together gives me f of 3 is negative 19. It works out. Okay? Much faster, much nicer, less math, really. You know, because it's multiplying and adding and easier stuff. Don't have to worry about exponents, all that good stuff. Okay? Where that leads us to, then, oops, actually, I lied, not quite yet, one more. So you try these two. Find me those two using synthetic substitution. So we want negative 3 to go into there, and my coefficients are 1, negative 6, 5, and 12. 1, negative 3, negative 9, 27, 32, negative 96, negative 84. I get negative 84 for that. Agree? Yeah. What's up?
Oh no, hold on, yeah, never mind.
Okay. That happens.
I'm in the wrong mood today. I must be overthinking today.
Oh, I get 0. Yes? Yeah. Okay. We'll get back to that one in a minute. Okay? So there's our two answers. Love it. Okay? So, see if this works now. It didn't work the first class. Let's see if it works now in this class. Come on, work. Where's my, there you are.
Wow, you guys really love that old school long division of polynomials. What if you had a fancy way? Yeah, like ketchup, right? I'm talking about maybe motor oil. Synthetic motor oil? No, synthetic division. Yes. Here's our topic. Right. What do we need to do? We need to be dividing by special linear factors in order to use synthetic division. So let's talk about how we're going to get into this game. All right. Special linear factors. Yeah, something like these guys. Okay. This is not a special linear factor. Why? Because my leading coefficient of my variable is not 1. What makes a special linear factor? A special linear factor has coefficient 1 and degree 1. An example of a special linear factor is x minus 2. Okay, this is x minus c. Okay, what goes outside of our box? The opposite of c, or whatever's going to make our denominator 0. I'm ready for an example. Up here, yes. Am I dividing by a special linear factor? I am. So then, okay. Zeros go outside of the box. What makes that denominator 0? Minus 1. Zeros go on the outside. Coefficients go on the inside. Coefficients are the numbers in front of the variables. Here we go. I'm going to put a 1. I'm going to put a 3. And and I'm going to put a 2. Oh, this is actually long division without the actual coefficients, and we need our special linear factors. So then what do I first do? Drop it like it's hot, drop it like it's hot. Minus 1 times 1 gets me a minus 1. Very nice. 3 minus 1 is 2. Okay. Minus 1 times 2 is a minus 2. Oh, and our remainder is 0. What does this mean? This means that x minus 1 is a factor of x squared plus 3x plus 2. You're going to be using something called the factor theorem to determine that. Yes, but that's neither here nor there. Where is it? Yes, we're taking 1 degree out of the numerator. It was a degree 2. So now I want to write my answer as 1 degree less than 2, which is 1. X plus 2 is going to be the quotient of those two polynomials. And then what? Yeah. And a flower. Now I'm up here. Okay. Yes. Am I dividing by a special linear factor? Yes. So what goes on the outside? Zeros go on the outside. What's a 0? Anything that makes that polynomial 0. What's going to make this polynomial 0? 1 is. Okay. And a different color. Yeah, 1 is on the outside. What goes on the inside? My coefficients. Yes. A 1 goes in there. A 2 goes in there. A minus 3 goes in there. And a 12 goes in there. Okay. So then I drop it like it's hot, drop it like it's hot. You know, snoo. Dun, dun, dun. Yeah, whatever. That was my song with one of my ex-girlfriends. Yeah, and yeah, I went away, and I'm not gonna finish that story. Anyway, she dropped me like it was hot. Oh, messed up, right? She was a horrible person. No, she wasn't, really. Yes, here's a 1. This one times that one, put it there. That's a 1. 2 and 1 is 3. Tee-hee. This one times that one, put it there. That's 3. Tee-hee. Adam. None. Yes, this one times that one, put it there. 0. Oh, Adam, and you got 12. Oh no! What does this mean? Let's go through and rewrite our quotients. Yes, I had degree 3. This is gonna take it down a notch. I wish you'd take it down a notch. Hey, whoa. So instead of degree 3, it's now gonna be degree 2. So then, this is gonna be x squared plus 3x plus, no constants, but I do have a remainder. And how do I write that? I write it remainder over divisor. X minus 1. Fun. And then what? And a flower. And when I said I went away, I wasn't talking about like to the woohoo. Yeah, no. I had to go, do some work somewhere else. Here we go. What makes this denominator 0? 2. Yes. So I put a 2 on the outside. And then I put the coefficients on the inside. I put a 1. Then I put a 0. Why? Because I need a placeholder for my x to the 3rd term. Yes. So 0x to the 3rd plus 0x squared minus 1x plus 2. Okay. Oh, I need placeholders. On the outside, zeros. And then on this first one, drop it like it's hot. There's a 1. 1 times 2 is 2. Very nice, Adam. 2. 2 times 2 is 4. Sure, Adam. 4. 2 times 4 is 8. Great, Adam. That's a 7. 2 times 7 is 14. Adam. That's a 16. Okay, that's my remainder. I'm dividing by a linear factor. I need to take it down a notch. This is x to the 3rd plus 2x squared plus 4 x plus 7 plus remainder 16 over divisor x minus 2. Look at that one. Oh, yes. Yeah, I do think it's a hammer. Because it's hammer time? No. Because we nailed it.
Okay. So that's what we're going to be doing today, and I just like that video, so that's why we had to watch it. So we're going to be doing synthetic division. Synthetic division is just like synthetic substitution, and it's much faster than long division. If you want to keep doing things the long, drawn-out way, that's fine. But if you've got one of those special linear factors, you can use synthetic division. Okay? So if I go back to this very last problem that we did over here, where f of 4 was a 0 of this function. Okay? That's where I got that from. Okay? So since f of 4 equals 0 of that function, that means that x equals 4 is a root, a 0, or a solution to f of x. And those all mean I'd even accept an answer to f of x. Okay? So any of those all mean the same thing. And that means then that x minus 4 is a factor of it. Okay? And we can use synthetic division because it's a special linear factor. Doesn't have an x or a coefficient on the x, okay? And it's a single linear one, okay? To find the other ones. Now, there's going to be 3 different stops that we can make along this route. Think about it in terms of riding a bus. Okay? So if I wanted to take a bus from here downtown to the 400 block, okay, I could stop anywhere along that way. Okay? I'm still on my way to the 400 block, but I haven't quite gotten there yet until I get off the bus at the 400 block. So for instance, the first bus stop that we would have on this route is we just straight up and simply can divide out the numbers. That's what was shown in that video. Okay? In this particular case, I would show that as, so f of x, so this would be x cubed minus 6x squared. I think it's plus 5x plus 12. Divided by x minus 4. Okay? And so we can do that. And I can say, well, so 4 is my linear factor. 1, negative 6, 5, and 12 are my other ones. And so then we go 1, 4, negative 2, negative 8, negative 3, negative 12, and 0. Okay? So the answer here, if we were stopping here, would be, so then I would say that's x squared minus 2x minus 3 would be my answer here if we were stopping just at dividing those two up. Okay? Okay? My second stop, or my second bus stop on this route is I can take and I can factor f of x completely. So f of x here is x cubed minus 6x squared plus 5x plus 12. Okay? We know that x minus 4 is a factor. We also know that when we divide this by x minus 4, we get x squared minus 2x minus 3. We just found that in stop number 1. Okay? So I know that f of x is what's written in blue there. But I can take this a step further. Side note, you might want to write this stuff down because this is going to be what you're going to be doing here for the next 2 weeks. Okay? And I can factor that trinomial. That trinomial can factor to be x minus 3 and x plus 1. So f of x in fully factored form, or complete factored form, would be x minus 4 times x minus 3 times x plus 1. And that's a stop that we can make along this journey. We can factor it completely. The last stop that we want to get to is we want to get to solving. We want to get to solving the equations and finding all the zeros, all the roots, all the good stuff, all the answers, if you will. So we know that f of x equals x cubed minus 6x squared plus 5x plus 12. And we know then that that is factored to be x minus 4, x minus 3, and x plus 1. So we know all of that. So then what we can do is we can take our roots, our factors, and we can set them equal to 0. We get 4, we get 3, and we get negative 1. And those would be the 3 solutions, the 3 roots, if you will, to f of x. Okay. Now, it is going to be very crucial for you as an individual to read the problem. Because right now, I can give you 3 different types of problems that all look exactly the same. Okay? So if I say divide, if you just see the word divide in the problem, that's stop number 1. If you see the word factor completely, that's stop number 2. Or if you see find zeros or find the solutions or solve, that's stop number 3. Okay? Let's try some. Which bus stop are we at for this particular problem? Are we at stop number 1, stop number 2, or stop number 3? 1, because it just says divide. Okay? Right? So it just says divide, so we just need to divide it out. Please, at this time, divide out this problem. So I need to figure out what makes that be 0. And so I would say, well, let's just set it equal to 0. And then that's going to be negative 2. So negative 2 is what I'm going to use in synthetic division. Coefficients in order: 1, negative 1, 4, and negative 10. 1, negative 2, negative 3, 6, 10, negative 20, negative 30. So it started out as a cubic, drop it down 1, that means I get x squared minus 3x plus 10 plus negative 30 over x plus 2. Yes? Questions, comments, concerns, clarifications? Okay. Try that one. So if x minus 3 is a factor, that means that x equals 3 is the 0. So the 0 is what I have to divide in. So that's why I have 3 there, is what I'm dividing in. And when it's all said and done, because x minus 3 is a factor, what should be in that purple box as my remainder? 0, because otherwise it's not a factor. There would be a remainder. So in the end, I should get 0. So that's a quick check there for you. Okay. 2, 6, negative 5, negative 15, add is negative 12, 36, and I end up getting 0. Okay. So this ends up being x minus 3 is the first factor that I divided into. What's left over is 2x squared minus 5x minus 12. Okay. So now, that's what f of x now is equal to. Now I have to ask myself if this other one, this trinomial here, is factorable. Now let's try 2x, let's try x. What are we thinking? Negative 3 and positive 4? In that order, left to right? You think so? Let's check it. You want me to do the right one or you want me to do the wrong one? Okay, the right one is positive 3 and negative 4. Because then here I get positive 3x and here I get negative 8x. And those together give me negative 5x. Your way would have given me positive 5x. Okay? Yeah. So it's close, just off by one side. Okay? So that is factorable. So then my completely factored function, f of x, would be x minus 3, 2x plus 3, and x minus 4. Okay. Good on that? Okay. There we go. Find all the other zeros of the polynomial, of that polynomial, I should say, if one of them is not. So if 9 is a 0, then x minus 9 is a factor. Huh? Need that. So f of x would be x minus 9 times 2x squared plus 8x plus 1. Okay. This one is going to give me a 0 of 9, which we already had. That one was given. Okay. And I don't have to find that one because it said I already found that one. This one is not factorable, but I still got to set it equal to 0. And I still got to solve it. But I can't factor it. So when I can't factor it, what do I got to use? What do I got to use? I can't factor it. I need to solve it. What do you mean? I'm going to use quadratic formula because it's a quadratic. Yep. So that's going to be minus square root of b squared minus 4ac all over 2a. So that's going to be x equals negative 8. 8 squared is 64. 4 times 2 is 8 times 1 is still 8. All over 2 times 2, oops, 2 times 2 here. I lost my 0. 2 times 2 is 4. So that's going to be negative 8 plus minus the square root of 56 all over 4. Square root of 56 is the square root of 4 times the square root of 14. So that is 2 square roots of 14. All of them can be divided, all the outside numbers can be divided by 2. So we get that as our other 2 zeros. Okay. Questions, comments, concerns, clarifications. Again, reading the directions is going to be crucial for you because it's going to tell you where to stop. Okay? You can't get to that answer, you can't get to stop number 3 without going through stops 1 and 2 first. Likewise, you can't get to stop number 2 without doing stop number 1 first. Okay? So you got to go in order. Okay? There is the worksheet for today. I looked this morning and I'm like, oh, it wasn't posted. I must not have clicked save when I posted it this weekend. So it is up now, ready to go, and I'll have copies for you tomorrow, hard copies for you tomorrow in class if you need one. Okay? But I think it's only 6 problems, so it won't take you very long. Plus you got synthetic